So hello and welcome everyone to the YouTube channel of Infinity Learn by Sri Chaitanya. Okay students, so in the series of rotational motion and rigid body dynamics, I am going to start one very important topic which is known as angular momentum. Okay. Now students generally have phobia about this topic, they don't understand what is angular momentum, and to the point of in the preparation of their examination they make it very difficult. Okay. So I just want you to understand, you are making it difficult just because it's a part of rotational motion, right? That's why you are making it difficult. Okay, it involves angular parameters, that's why it looks difficult to you, but it is not like that. It is very simple topic with a very simple concept and with very simple applications. Okay, so here I'll tell you how to understand, how to deal with this concept by understanding it properly. Okay, so I am Ravindram and let's begin this topic. So first of all, let's understand what is angular momentum. Okay, so what is angular momentum? It is denoted by vector L. Okay, it's an angular parameter. Okay, now this is basically, it is defined as moment of momentum. Just like we define torque as moment of force, we define angular moment as the moment of momentum. Okay, and its formula is vector L is equals to vector R cross vector P. So सबसे पहले हम बात करेंगे किसी एक पॉइंट मास की, जैसे कि यहाँ पर एक पॉइंट मास लिया हुआ है, ठीक है, वी हैव अ पॉइंट मास हियर m. Okay, so let's take it here, understand it here self, that we can use for reference later on. Suppose there is a point mass m, okay, and it is moving with a velocity vector v like this. Okay, and we need to find out its angular momentum about this point of rotation. This is the point of rotation, right? So what we will do, we will join it. This is the vector joining the point of rotation or axis of rotation with the particle of which we want to find out angular momentum, right? It's very simple. Then we will extend it, and this is the angle between them. We will say this is vector r. Then as we did in torque, vector r cross vector f becomes vector tau. Here also we will say vector L is vector r cross p, vector r cross p. Now what is p? P is mv, so you will say vector r cross m times vector v. So what we can do is, we can say vector L is nothing but m times vector r cross vector v. Do you understand? So mass times vector r cross vector v, this is the angular momentum of this particular particle right now, which is moving in a straight line. Achha, okay. You might be wondering, sir, this particle is not performing any angular motion. Okay, it is not performing pure rotation, but about this point it might perform angular motion. Okay, why? Because the position vector which is going to join this particle is constantly going to rotate. See, you might be wondering, sir, why we are involving the concept of angular momentum on the particle which is performing simple linear motion. You might be wondering this, and it's logical. Okay, ये आप logical है. जैसे आपने बोला कि सर ये पोजीशन वेक्टर है अभी, अब पार्टिकल इधर पहुंच गया, ये हो गया उसका दूसरा पोजीशन वेक्टर. पार्टिकल जैसे आगे बढ़ रहा है, आप देखो उसके पोजीशन वेक्टर बदलते जा रहे हैं. तो पहले एंगल थीटा 1 था, अब एंगल थीटा 2 हो गया, अब एंगल थीटा 3 हो गया. कैन यू सी दैट? तो भले ये पार्टिकल तो अपने आप में एक स्ट्रेट लाइन मोशन परफॉर्म कर रहा है, द पार्टिकल इज परफॉर्मिंग अ रेक्टिलिनियर मोशन, बट अबाउट दिस पर्टिकुलर पॉइंट और दिस पर्टिकुलर एक्सिस आई कैन से, सिंस द पोजीशन वेक्टर जॉइनिंग दिस पार्टिकल at different times is changing its angle with the x-axis, that means it is rotating. So hence with respect to this point or axis, this particle is definitely performing some angular motion, because the angular position of the object is changing with respect to this point. What is changing? The angular position of the object constantly is changing. So that is why, yes, we can involve the concept of angular momentum for a particle who is definitely performing a rectilinear motion. Is it understood? We will be understanding how to use angular momentum in purely rotating body also. This is not a purely rotating body, this is a body performing simple rectilinear motion, but about this particular point its position vector is constantly, its angular position is constantly changing. That is why we can say about this point this is definitely performing angular motion, and hence we will find out the angular momentum of this particular point mass about this point. It is possible. Okay. I hope you are understanding my point, right? It's very simple. So let's take the help of examples. And what is the unit? It's very simple. What is the unit of momentum? It is kg meter per second. Angular momentum will be kg meter square per second. Okay, so I don't want to get into those things. Kg meter per second into meter. So it will be kg meter square per second. Anyways, let's move ahead now. Okay, so there are some few questions I want to discuss with you. First of all, a particle having a mass 2 kg. So here in this question, mass of the particle is given 2 kg. Now the velocity of the particle is given. Yes, perfect. Then what they are asking, find the angular momentum of the particle. Okay, about which point? Origin. When it is at this particular point. So see, they are mentioning a lot of factors. They are mentioning about which point. Okay, that is origin. Where is the particle when you want to find out angular momentum? It is at 1, 1, 0. So mass, velocity, point about which rotation is happening, or point about which we need to find out angular momentum, and the position where the particle is currently. Okay. So what we will do, we will first draw. हमेशा याद रखना है बच्चों अपने को, whenever we are solving a question in physics, we need to first draw what is given in the question. If it needs, we have to draw it. Okay, if there is a requirement, then we have to definitely draw whatever we can to understand the question properly. Okay, so we will say this is 0, 0, 0. Where is the particle? 1, 1, 0. Now the velocity of the particle is 2i cap plus 3j cap, somewhat like this. Okay, this is vector v, and I'm pretty much confident what is vector r. It is the vector joining the point of rotation with the particle. Can you see that? This is vector r. Okay. Now here we will be discussing two things, because we have to find particularly vector form. Okay, so we will say that this is vector r, this is vector v. Technically vector p will also be in the same direction, right? So we will say what is vector L? Vector L is m times vector r cross vector v, m times r cross v. So first of all, what is vector r? You will say vector r is this vector which is joining these 2 points. So it is obviously I cap, 1 I cap plus 1 j cap plus 0 k cap. Okay, so technically vector r is I cap plus j cap. Got it? Now what is vector v? Vector v is given 2 I cap plus 3 j cap. Got it? Now what do we need? Vector L. So we will do the cross product here, and in the cross product we will say vector L is equals to, mass is how much? 2 kg times I cap, j cap, k cap, and r cross v, 1, 1, 0, 2, 3, 0. Okay, so what is going to happen? Both the vectors, vector r and vector p, are in the xy plane. Can you see that? Now obviously their cross product will definitely lie along the z axis, so definitely the result will be only k cap. Are you understanding? So vector L will become 2 times k cap 3 minus 2. That is 3 minus 2 is 1, so answer is 2k cap. Now how to find out the direction? One more method is, that is we are doing vector r cross vector v, yes or no? So see, this is, let me erase this thing. Okay, this is 1, 1, 0. Anyways, so this is your vector r. We have already studied this in torque. Okay, so r cross, this must be the angle theta. So r cross v, what is the answer coming? R cross v, this. Okay, inside. So what is happening here? Is there any mistake? Okay, I have drawn it wrong. The mistake is, the answer is correct, I have drawn it wrong. Vector r, because according to the diagram is not right. According to the diagram, I guess the thing is somewhat like this. It is coming k cap, that means vector r is this, and vector v must be somewhat like this. Yes, now it will be correct. Now our concept will perfectly match. Now we can say yes, it is 2k cap. So r cross v if we do it, obviously this is 1 comma 1, so this is 45 degrees and this is what, 2i cap plus 3j cap, definitely 3 by 2. So this angle will be greater than 45 degrees. So vector v will be here and vector r will be here. Anyways, vectorially you have got it, vectorially you have got the answer, and when you do r cross v, so this is where the vector is coming, that means along k cap. Do you understand this? Okay, so let's move ahead now. So how do you find out the direction? The finding of direction is very simple. Now one more thing, students, before I solve this question, when I say vector L is vector r cross vector p, then you will say, sir, it is nothing but m times r cross v. Then you will say, sir, it is magnitude wise m into r into v into sine of theta, right? Now again there will be two ways to understand. One will be m into r into v perpendicular, that is v sine theta, or there is one more way, you can say L is m into r perpendicular into v, that means r sine theta. Okay, both ways. So what we are doing here, see, sometimes let's say let me take it here. Suppose this is a particle, okay, and this is vector r, this is vector r, and let's say this is velocity v, vector v. Now what we can do is we can break velocity into two components. One component will be along vector r, that is parallel component, another will be v perpendicular. Now this angle is theta, so this is what, v sine theta. Are you understanding, students? So either we can do vector r into v sine theta into mass, r into v sine theta into mass. This is our first method. Either we can go with this method, or what is another method? Another method that we can opt for is this. See, this is vector v, okay, this is vector r. Either we can break vector r into two components and we can write it like this. We can say, let's extend it. This angle is theta, right? This is r. So we can say that this distance is what, r perpendicular, or we call it r sine theta, right? Or I can call it here, this is what, r perpendicular, or so either we can say r perpendicular into m into v, that means this way. Are you understanding? So both ways are correct. Either you can break velocity into two components, one along r, one perpendicular to the r, and you say mass into r into, that is distance, into perpendicular component of velocity with r. Okay. Now second case, what we are doing, we can break vector r into two components and say one component along velocity and one component perpendicular to velocity. So what will happen, the component which is perpendicular to the velocity, we will take r perpendicular and say mass into r perpendicular into velocity. So both ways will work in different types of questions. Okay. So whichever way you find easy in any question, you can go with that method, there is no issue. I hope you understood this thing. Right. Now in this particular question, what they are saying, a particle of mass m starts moving from point O, 0, d. Okay, 0, d. It starts moving with a constant velocity ui cap. Definitely it is moving in this direction, ui cap. Okay, fine. Find out its angular momentum about origin at this moment and what will be the answer at later time. Okay, that means right now, and when it is here after some time, let's say t. So what will be the angular momentum at this moment also? Okay, so this thing we have to figure out. Okay, let's do this question. Come on. First of all, I need some space here. Okay. So students, quickly look here. We will say right now at this particular moment when it is here, so this is your r, this is your r, and this is already perpendicular to your velocity vector, yes or no? That means you can say angular momentum is m into r perpendicular into v, where r is r perpendicular is already given to you, that is d. So m into d into u. What is the velocity? U. So answer is m du. And if you want to ask, sir, what is the direction? Please tell the direction also. Okay, fine, no problem. You will say, sir, this is velocity vector and this is your vector r, right? So when you say r cross v, so where it is going? Inside. Okay, that means inside means minus k cap. So r cross v with right hand, r cross v, where it is going? Thumb is going inside. Okay, so you will say L will be, vector L will be m du into minus k cap, if we consider this as x and this as y axis. Okay, now this particular case, after some time t, again this is vector u. Now what is happening? Now we have some angle here, theta, right? And you can consider this to be vector r this time. Again r cross u or r cross v we will do. But here what we will do? We will say, in order to find out angular momentum, this time it is better we break, this time it is better if we break r into two components. If this is theta, this angle is also theta, okay, or this angle is also theta, right? So you will say, sir, this is r perpendicular, which is again what? R sine theta is this perpendicular, what is this? D, it is D. So you will say it will be m into r perpendicular into velocity, m into d into u, again same result. And direction wise also, what is the result? Tell me, what is direction wise? Again r cross v, inside it is minus k cap. That means angular momentum is not changing, it is constant if the particle is moving like this straight. Do you understand this thing? Is it clear? So we have understood what is angular momentum, how to find out the angular momentum using this formula also, and how to check the direction of angular momentum by using right hand thumb rule and doing r cross v. So wherever vector r is, take your right hand in that direction and move it in the direction of velocity. Okay, again I will give you two examples once again. If this is vector r and this is vector v, and again another one is if this is vector v and this is vector r, what will you do? R cross v like this inside. So here angular momentum is into the page, into this plane, right? And here r cross v don't do like this, okay? You have to curl like this. So if r cross v you cannot curl like this, you will say r cross v. This is how you will curl right now, okay? You will curl your hand right like this. Vector r cross vector v. Where is the thumb coming? Outwards. So dot. Clear everyone? Okay, fantastic. So let's move ahead now. Okay, so there's a question given to us. A particle of mass small m is projected on the horizontal ground with initial velocity. Fantastic. You can read the question. Pause the video, read the question, no issue. Okay, so these are three positions they have asked. Can you see this? Position number 1. So this angle is given theta. Okay, fine. And this velocity is given u and the mass of the object is given m. So obviously at the topmost point its velocity will be u cos theta, and here its velocity magnitude wise will be u again anyways, okay, and it will strike at the same angle theta with the horizontal. Cool. Now we have to find out the angular momentum, okay, of the particle about the point of projection. So about the point of projection when it just starts its motion. Okay, when it is just starting its motion, vector u is actually passing through the point of rotation. That means right now at initial position, if I say r is 0 and hence L is 0, because if the particle is at the point of rotation itself, then vector r will be 0 na. The distance between the point of rotation and the particle is 0, so obviously angular momentum will be 0 right now for the first case. So get over with it. Now let's come to the second case. Second case is when it is at highest point. Okay, when it is at highest point, then this is your vector r. Can you see that? So obviously what we will do, again there is a very beautiful method. What we can do is, we will say we can break vector r into two components. This is your velocity vector, right? This is your velocity vector. So we will break r into another component, that is this is r perpendicular. And you know this height, this distance you already know, that is capital H. So what you will do? Again you will say, sir, in the second case it is very easy. Angular momentum will be m into r perpendicular into v. So m into height is how much? U square sine square theta by 2g into u cos theta. So it will be mu cube sine square theta into cos theta by 2g. This is L. And if you want to give it direction, then also very simple. This is the direction of vector r, r cross v, where it is going inside. So it will be minus k cap. Got it? Yes or no? Fine. Now last one. If the object is here, then see, you will say this is our vector r. Okay. Now this time it is better if you break velocity into two components, right? So let's break. You will say this is u parallel and this is u perpendicular. What is this? U sine theta. So it is better right now. And what is this? Range. You know this distance, range. So in the third case or the last case, you will say, sir, angular momentum will be m into r into v perpendicular this time. So m into r is how much? Range? U square sine of 2 theta by g into v sine theta, into v sine theta, u sine theta. It will be u sine theta. It will become mu cube sine 2 theta into sine theta upon g. And what is the direction? You will say, sir, this is the direction of vector r. So r cross v, where it is going? Inside, minus k cap. Okay, so direction of angular momentum has not changed here. Is it okay? Do you understand? So I have taken all the three possible cases here. One where the angular momentum is 0. Second where you have to break vector r into two components. That means you have to take r perpendicular and use this formula. And third last case where it is comfortable or it is easy to use this formula, m into r into v perpendicular. So that's what I am saying. Depending upon the situation in the question and depending upon how many questions you practice, you will get an idea which concept to use where in the question, right? So let's move ahead and let's understand this. Find the angular momentum of the object of mass 4 kg performing UCM. Okay, so let's come to the angular momentum of the particles who are performing pure circular motion, okay, who are rotating about a point. So it's very simple. If you say that this is mass m, this is its velocity and it is rotating, let's say with an angular speed omega. Okay, it's very simple. So you will say, or this distance is r. So you will say, sir, v is equals to r omega, number 1. Number 2, here r is equals to r perpendicular is equals to capital R, right, because this is your vector r. So when you find out angular momentum, it will be m into r perpendicular into v, right. So m into r into v. So L will be mvr, okay, this mvr, and this is vector r if you say. So r cross v, what is the direction right now? If it is rotating like this, so direction is outside, and if it is rotating like this, direction is inside. Anyways, so L is what? L is mvr, okay. Another thing we can do is L is m omega r into r such that it is m r square into omega, where mr square is its moment of inertia also. So it can be I omega as well. That means moment of inertia of this point mass into omega. This is also one method. So here automatically vector L can be seen to be in the direction of vector omega. Vector L can be seen to be in the direction of vector omega. That means if omega is outside, vector L will also be outside. Do you understand? So if a particle is performing circular motion, then You can say angular momentum is mvr or I omega, and vector L is parallel to omega. Is it understood now? I hope it is clear. Now let's understand. Let's take a very nice question here. I have a very good question. Okay, now in the previous question, students, in the previous question, can you see that the direction of vector L was constant and magnitude is also constant? Suppose it is rotating with constant velocity, it is given UCM. So in this particular concept you can say vector L's magnitude, that is mvr or I omega, will remain constant if it is UCM. If it is uniform circular motion, it will remain constant, plus direction is also constant, that is along vector omega. So both things are constant with time. Now there is one question which has been asked in previous year JEE. What they are trying to ask is this. See, a particle is performing circular motion like this, a conical pendulum. Can you see? This is a conical pendulum, sort of a conical pendulum. So it is performing circular motion like this. Do you understand? Like this, it is performing circular motion. Okay. Pardon my drawing. Oh, yeah, it's not a tangent. I cannot draw it like this. Just wait. So when it is here, like this point, like this. Okay. So that's what I'm trying to say. So it is moving like this. Okay, with a velocity v, and this length is L, okay, and this radius is capital R. Mass of the object is m. So they are asking what is the angular momentum of the object, and is the angular momentum of the object constant? Is the angular momentum of the object constant? So two things we need to understand. See, in the previous question, angular momentum was mvr, it was constant magnitude wise also and direction wise also. So let's check it here. Are both the conditions matching here or not? Okay, so it's very easy. Let's begin. So we will say, sir, it's very simple. What is the formula of angular momentum? You will say, sir, it is very simple. How much it is? Vector L is vector m times vector r cross vector v. So vector L is mass times vector r cross vector v. Okay. So in this particular case, if this is the point P, okay, this is your vector r, and can you imagine that vector v will be perpendicular to it? Suppose this is your vector r. It's a conical pendulum, right? So can you see that vector r and vector v are already perpendicular to each other? They are already perpendicular to each other, right? Like this it is rotating, na? Like this it is rotating. Can you see that? So it is already perpendicular, so there is no problem in it. Cannot draw it like that, but I hope you are understanding. If this is circular motion, right now this is velocity, and they are perpendicular to each other right now. Okay, so you will say, sir, vector L or magnitude wise it will be m into r perpendicular into v, and in this case also r perpendicular is this length itself into v. So answer will be mvl, right? Now what is the direction? This is something very important here. See, if you are saying, sir, this is vector v right now, and this is your vector r, this is your vector r, right? So when you do r cross v, this is your vector r, this is v, so r will be extended here, r cross v, like this we can write, okay, like this we can show vector r. So we will say we always extended, na? We always extended, okay. So vector r cross v, when you do it like this, look here, this is vector v, this is vector r, so it will go like this. So I will say r cross v is coming like here in this direction. Can you see that? It is coming here in this direction, outwards. Can you see that? Like this. This is vector L. Okay. So what is happening? When you are turning, vector L's direction is also changing constantly, like this, like this, like this, like this. Can you see that? So the way the body is moving, suppose this is the velocity, so vector L is here and this is vector r, suppose this is vector r and this is vector L, this is vector v. So it is constantly changing. Can you see vector r, vector v and vector L? So vector L's direction is constantly changing. So in this particular case I can say yes, the answer is MVL, but direction is constantly changing. Okay, direction is constantly changing. Got it everyone? Clear? It's very easy. Now angular momentum of a rigid body rotating about fixed axis. Now this is very simple. I have taken a rigid body here, okay, and let's understand there are some point masses here, m1, m2, m3 like this, okay. It is made up of lot of point masses, okay. So let's understand, if every point mass is rotating with omega, okay, so we will say that angular momentum of every point mass will be how much? See, they are performing circular motion, so you will say angular momentum of every point mass will be m1 v1 r1, because they are performing circular motion. Then L2 will be what? m2 v2 r2 up till whatever it is, mn vn rn. Yes. Okay, now what is v1? v1 is r1 omega, v2 is r2 omega and vn is Rn omega, and you can see that the direction of angular momentum of every particle will be in the same direction, because the sense of omega is same for everyone. So when you write complete vector L, it will be vector L1, vectorially we are adding vector L2 plus vector L3 up till vector Ln, okay. So we will say vector L is ultimately what is here, direction wise we know what is the direction, so it will be m1 v1 r1 plus up till mn vn rn. Let's say the direction is n cap, that means this direction, the vertical direction is n cap, okay, let's say it. So vector L will ultimately become m1 omega r1 square plus m2 omega r2 square up till mn omega rn square. Got it? So finally we will say vector L will be m1 r1 square plus m2 r2 square up till mn rn square times omega. And I can say that since omega is also a vector quantity, I can take it out and say that omega times n cap will be vector omega, right. So here it will become vector L will become, this is what, m1 r1 square plus m2 r2 square plus mn rn square. That means I am trying to find out the moment of inertia of the complete body. So it will become I times vector omega, same thing coming again, okay. Now the problem with this is this rule is valid, but for some symmetrical objects there are certain cases where this is also not valid, okay, but we will not be discussing those cases. So it is valid mostly in all the cases right now for you. So vector L becomes I times vector omega, okay, for any body which is performing pure rotation about certain axis. So you need to be very careful. I should be the moment of inertia about that particular axis about which the body is performing pure rotation. You get it? So this is one way of finding out the angular momentum for the bodies who are performing pure rotation, students. Now listen very carefully. Let's take an example here. Suppose we have a ring, okay, and we want to find out its moment of inertia about this not moment of inertia, ring of mass m, radius r, and it is rotating with angular speed omega. Let's find out its L about this axis x dash. Okay, so you will say, sir, this is one of the diametrical axis. So L will be I about x dash times omega, right? So it will be how much? It will be m r square by 2. Everybody knows for a ring about diametrical axis, moment of inertia is mr square by 2 times omega. So this is how you will get the value of angular momentum for this continuous body performing pure rotation about this particular axis right now. Okay, we can take some other examples also. Okay, let's take the example of a disk rotating about this axis. You know what is the moment of inertia of this axis, about this axis? Again, applying parallel axis theorem, you will say, sir, this is, it is rotating like this omega, okay. So you will say, sir, this is ICOM, this is I. So you will say, sir, I is what? ICOM plus M, what is this distance? Capital R square. Now what is ICOM? MR square by 4 plus MR square. So what will be I? I will be MR square 5 MR square by 4. Do you understand? Now once you know I, if it is rotating with omega, you can say, sir, angular momentum will be I about that particular axis into omega. So it will be 5 by 4 MR square into omega. Do you understand, students? Okay, it's very easy. 5 by 4 MR square omega, that will be the moment of. So this you can do for any symmetric body. You just have to find out the moment of inertia about that particular axis about which the rotation is happening. Multiply it with the angular speed of the object, you will get the answer. Okay. So this is all about angular momentum. Now I would also like to tell you angular momentum of a body angular momentum of a body performing combined motion, but I will cover that when I will teach you combined motion. So in the video of combined motion, that means pure translation and pure rotation clubbed, so that means rotational plus translation motion. When we will be discussing combined motion, there we will discuss the angular momentum of the body performing combined motion. Okay, so wait till then. So I hope this much is clear and you understand these things properly. So that's all for today. Thank you, students. Subscribe to our channel and keep learning infinitely.